All right, so we're going to start matrices. This is extra. You can learn to do this or not, but I do warn you that it'll happen at post-secondary, and you may be lost if somebody doesn't use the right language for your brain. I hope I do here. So first of all, I need to tell you what a matrix is, and then we can take care of this question, which is the same kind of question as we've been doing. So I'm going to do a little setup here and label some things. So basically what you can do, or what you're supposed to do with a matrix, is take out all the letters. So just so you know, this is the pre-spreadsheet math. So somebody did some work with matrices, matrix, singular, matrices, plural. Somebody did some work with this, and then somebody else turned it into Excel, for instance. So this is pre-spreadsheet on computers. So what you do is you put this big square bracket. It's got to be big enough to accommodate 3 lines in this case. 3 lines of work, or 4 if there's 4 statements, or 5 if there's 5 statements, or 2 if there's 2 statements. And then you just take the digits, but they have to be in order, so the coefficients. So I can put 4, then over a little bit, -2, then over a little bit, -1, then in the second one, 3, over a little bit, here's the y, over a little bit, placeholder 0 for the z. So that's kind of like long and synthetic division, if you think about it. Don't think about it too hard, because it's completely different. And then 1 for the x, +1 for the y, +1 for the z. Now this is the coefficient matrix. This is not what we're after. There's also a column matrix, and that is the stuff that comes after the equal sign. So you can't have the D sitting on the left. The D has to be sitting on the right-hand side of the equal sign. So you're going to have to move that over if somebody doesn't provide this setup. Letters on the left, numbers on the right. So what we have to do, and I'm going to show you the neat way and then the not so neat way, what we have to do is make an augmented matrix, so a combo of these two. So 4, -2, -1, 3, -1, 0, 1, 1, 1. And then what you'll see in textbooks who have much better handwriting than me is you'll see this little bar, and then they'll put down the column matrix and then close off the matrix. Now, I can't do that. I'm not neat enough to pull that off, so what I do for my augmented matrix is I put a line. That's a little wider than I would just like toss a line through that, and then my matrix would be there. And this is what we work with. So this coefficient matrix, this column matrix, and what we end up working with is this one, which is the augmented matrix. And you do not need to know the name of this stuff. I'm just giving you some information. All right, so let's go to the actual question, which is this one. So what I do is I do all my matrix work on this side of the page and all my scribbling on this side of the page. That's how I set it up personally. So I'm going to continue to set it up that way because that's how my brain works. So let me make the matrix the same as I did before on the other slide. So 4, 3, 1. You can build it however you want as long as you have your X's, then your Y's, then your Z's. Boom, line to say that that's the equal sign. 12, 9, 5. Now, if you didn't have it there, there's nothing to say that this wouldn't be a coefficient matrix where this is W, X, Y, Z. So this line represents the equal sign. Okay, so what you want to have happen, if possible, and I'm going to show you a whole bunch of little math abbreviations. What you want, if possible, is, let me see if I can get a color, is you want these to be 1s and these to be 0s. Now, if you can make these be 0s, then you'll be able to say 1x equals whatever ends up sitting here. and 1y ends up being whatever's sitting here, and 1z is whatever ends up sitting here. So that's kind of what you're after. Before we even start this stuff, though, we should do what we did in the elimination and substitution style. Oh, water alarm. Hang on. Even though I'm in my living room, I do not have any water handy. I'll drink it after. Okay, so what we want to do is we want to see if we can figure out what kind of solution we're going to have for this before we even start. So that is doing the triple scalar product. So I'm going to do that over here. So again, it's n1 cross n2 dot n3. That's our triple scalar product. So I'm going to take 4, -2, -1, 4, -2, -1, n1, and cross it with 3, -1, 0, 3, -1, 0. Now, if you used n3, that's not good. If you used n3 cross n2, it's not going to make one bit of difference, as long as you use n1 back here. So get rid of this. So -2 times 0 is 0, minus +1. -3 minus 0, -4 minus -6. So that's -1, -3, 2 is the result of the cross. And then I have to dot it with the remaining normal, which is 1, 1, 1. And I'll get -1 plus -3 plus 2. And that is -2. But what's more important is that it's not equal to 0. And if it's not equal to 0, the result of this should be a point of intersection. So it shouldn't be a line of intersection or any of the other 8 possibilities. It should be a point of intersection. Another thing you should check beforehand is the scalar multipleness of these. If you have parallel, distinct, parallel, coincident planes, then you want to find out that information before you start all this matricey stuff. So like I said, you want ones right here. So one of the instructions that you can do, and you're supposed to put the instructions beside one of the lines, or the line that I guess you're replacing, is this is row 1, this is row 2, this is row 3. So I'm going to say that I want to interchange row 1 and row 3. And you may think to yourself, this is not a very good thing to do with all this writing, but I mean, that's the annoying part of matrices, is the amount of writing. So there's my row 3 in place of row 2. Sorry, my row 3 in place of row 1. Here's my row 2 as it is. And you may think this is a worthwhile line or not. And this is my row 1 in place of row 3. And every typo messes something up, so you got to be super careful. So now what we want to do is we want to get this to be a 0. We can get the ones after. I've forced this one into place, so it's one less thing to do later, which is why I believe it's worthwhile. So what you want to do, I mean, if you don't necessarily have this ability, is you want to take and you want to replace this with a 0. That's the intent, so I'm putting my instruction beside the row 2 because that's where I want the replacement to happen. So I'm going to take row 2 and row 1. I'm going to multiply row 1 by 3, and then I'm going to subtract. So essentially this is elimination without all the letters. So watch me scribble off to the side. So this is what helps me from not making a typo, but still doesn't guarantee it. Here's row 3. Here's 3 row 1 times 3 times 3 times 3 times 3. And then I'm going to subtract 0, -4, -3, -6. And I will keep my row 1, and replace my row 2, because that's where I wrote the instruction, beside the row 2. Now, I think it is a colossal waste of energy handwriting, especially with me and my hand cramp right now. I also want to get this to be a 0. So I can do a second instruction, this time beside row 3. So I'm going to take row 3 and row 1. I'm going to times row 1 by 4. And then because they're both positive, I'm going to subtract. And that is going to happen down here with my scribbles. So here's row 3 times 4 times 4 times 4 times 4, subtract 0, -6, -5, -8. So I've done 2 things for 1. Now, over here on the side, I'm just going to give myself a little hint or a little thing to remember to tell you. My first step, aside from interchanging, my first mathematical step is using row 1 both times. So now, the object of the game is, yellow, to get this to be a 0, because then I can work on these being 1s or whatever the case is. So now I have to do more scribbling. It means that I'm working with row 3, and it also means that I must work with row 2. And the reason I have to work with row 2 and not row 1 is I don't want to undo this 0, and if I use row 2, which has a 0 in that position, I won't undo all my hard work. So basically I'm playing common denominators with these 2 numbers. So I'm going to take row 3 and make a 12, so times by 2. And I'm going to take row 2 and make a 12, so times by 3. And these 2 numbers are the same sign, so I will subtract. So scribble here. So row 3 times 2 times 2 times 2 times 2. Row 2 times 3 times 3 times 3 times 3. And 0 minus 0 is 0. -12 minus -12 is 0. I have done what I intended. -10 subtract -9 is -1. And -16 subtract -18 is 2. So there is my replacement for row 3. Now, actually, I'm going to do something else, because I'm going to do 2 different ways of taking care of this. In that same line, I'm going to say, okay, I notice all these are going to be negative, so I'm going to times row 2 by -1, so that when I enter these in, they're all positive, which might be something you want to do. And then row 3 gets replaced with this. So 0, 0, -1, 2. And then just because, I'm going to take this row, row 3, and I'm going to times it by -1. And I'm almost done-ish. Now there is another method, but we have enough information now to answer the question. So if I times this by -1 and times this by -1, it changes things a little bit. And I don't know if you remember what this augmented matrix really is. It really is 1x plus 1y plus 1z is equal to 5. 0x, so 4y plus 3z is equal to 6. 0x is 0y, so 1z is equal to -2. So I have one of my 3 coordinates of the point of intersection that I was expecting. And before I forget, my second step was with row 2. All right, so Now that I've got this, I can backtrack through my lines. So that's row 3 translated. Here's row 2 translated. And now I can sub z is equal to -2 in here. And when I sub z is equal to -2, I'll only leave y. And if I only leave y, I should be able to solve for y. And get a value. So now I've got my z coordinate and my y coordinate, and I can backtrack even further. 1x plus 1y plus 1z is equal to 5, my row 1. And I can sub z is equal to -2 and y is equal to 3. So x plus 3 plus -2 equals 5. X plus 1 is equal to 5. So x is equal to 4. So now we can sum this up with, therefore, the planes meet at the point x, y, z. Round brackets for point rather than vector. All right, so I am going to disclose the second question. We're going to do this one a little bit differently, but it'll start exactly the same. I'm going to take a break for a hand cramp. So there is our second and last question before we move on to the other possibilities. So just so you know, what I've planned is that this particular note has all point of inflections. What you should start with every question, if you don't notice scalar multiples, is this. So you can pause while I pause, or you can try this to prove to yourself that it does not end up being 0, which means we have a point of intersection. So, break time. Whew. Okay, let's try this. See if I can get through this without a hand cramp. So, 3, -4, 1, 3, -4, 1, 1, -1, -1, 1, -1, -1. Normal from here and normal from there. So 4 minus -1, 1 minus -3, -3 minus -4. So 5, 4, 1, dotted with my remaining normal, which is 2, 3, -4. So that's 10 plus 12 plus -4. I don't even care what that is. I just know that it's not 0, so we have a point of intersection. All right, so let's start this matrix stuff. Now, I do want to give you another hint, and that is, you know how I did that interchanging thing? You can do that at any point in anything if it helps you. If it's at the beginning, what I personally think you should do is write whatever has the 1 first in your matrix, and then the other two are just a little crapshoot. Line for the equal sign. All right, so the work that I'm going to do is trying to get that 3 in now row 2, and the 2 in row 3 to be zeros. So remember that your work is with row 1. So this is what I'm concentrating on right now. I'm going to take row 2 as it is, and I'm going to take row 1 and triple it, and then I'm going to minus them to make a 0 in this position. And I'm writing it beside that row because that's the row that's getting replaced. So scribble here. So row 2, and I do this so I can backtrack on my work in case I make a mistake. So 3, 3, 3, 3. Subtract. 0, negative 1, 4, 14. That is my replacement for row 2, and I have achieved what I wanted to achieve, which is a 0 in that entry position. So now, same step, I'm going to take row 3, I'm going to double row 1, and I'm going to subtract. So, like I said on the previous slide, all my work to do this stuff is with row 1. I will come back to that. So, here's my scribble work. Row 3, row 3, row 3, row 3, times 2, times 2, times 2, times 2. Subtract 0, 5, negative 2, negative 16. And if you're going to make a mistake, it's probably with the algebra. 0, 5, negative 2, negative 16. So now what I want to do is I want to get this to be a 0 so I can very easily state what my z is. And second major step, use row 2. So we have to use row 3 because that's what we're replacing, but our work is with row 2. So I don't have to do anything to this because it's a 5. I have to times this by 5 to make a 5, but it'll be a negative 5, so you're going to have opposite signs, and opposite signs means you have to add. If you subtract, you just won't get a 0. So my row 3 is sitting right here, so I can save myself a little bit of time, and I can times by 5, times by 5, times by 5, oh crap. Times by 5. And I can do what I said I was going to do, which is add. So 0 plus 0, 5 plus negative 5, negative 2 plus 20, and negative 16 plus 70. So 64, 54. And that's it for that step, to be honest. You want to write down what you ended up with this information. So those of you who don't like to show your work, number one, I don't know what you're doing in calculus and vectors. And second of all, you can't get away with not showing your work, because I have to be able to follow your steps to see if you get the right answer. So, unlike this question that we started with, where I could very easily make a 1 in this position, this one, you can't easily make a 1 in that position. Or can you? Actually, you can. You can divide by 18, which looks like this. And I'm hoping 18 goes into 54 3 times. That was me doing a math and thinking about things at the same time. So there's my row 1. There's my row 2. Here's my row 3, divide by 18, divide by 18, divide by 18, divide by 18. So now I can very clearly see that z is equal to 3. But like I said, I'm going to do this one a little bit differently. So now what I'm going to do is I'm going to go up the chart, and the next step is to make this be a 0 and this be a 0 all in the same step. Now, I'm going to erase that one so I can focus on one thing at a time. So what we did, major operations. We did a bunch of work, not the color I wanted. We did a bunch of work with row 1. Let me scribble here. Then we did a little bit of work with row 2. Then we took a little break. This isn't work with row 3. This is just reducing our row. Now we're going to have to use row 3, because row 3 has the most zeros of all the things, so you're not going to undo your damage. So I want that 4 to be a 0. So I'm going to take row 2, which is just fine with that being a 4. I need this to be a 4, so I'm going to take 4 times row 3, and I'm going to subtract them because they'll be the same sign. So here's row 2 times 4 times 4 times 4 times 4, subtract 0, -1, 0, 2. So this row is just fine. I have a nice replacement for row 2. Now I want this to be a 0, and I should also use row 3 to pull that off. So row 1, oh, they're the same number, but they're opposite signs, so I don't have to do any multiplying. That is a bit of a relief to me. So row 1, row 3, add 1, -1, 0, 3. I have achieved what I wanted to achieve. And in my little list over here, I'm going to say we just did 2 lines of work with row 3. So, maybe last step, if we're lucky. Remember what I said in the beginning. I want these to be 1s, or those to be digits, this to be 0s, which I achieved in both questions, and now I'm heading for this to be 0s. So, to back that up, this is what I want to achieve to be a 0 next. So, red pen, I have to use row 2 to pull this off because it's the only one with a digit in here that's going to help. So I'm going to take row 1 and row 2, and they're already the same number, so I don't have to do any multiplying. And they're the same sign, so I subtract. Now, I don't know if you noticed, with row 1 and row 3, I wrote it over here because my eyes do not let me avoid making typos with row 2, which I'm trying to avoid. However, with this one here, I think I'm good enough because row 1 and row 2 are directly on top of each other. So row 1, subtract row 2. 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 Now, can you see why I skipped over row 2? It's because it's not ideal. I don't have a 1 sitting here. That's what I want. I have a -1 sitting there. So I'm going to take this one and I'm going to times by -1. I don't have to, or I can divide by 1 over -1. And that'll achieve me being able to spit out the answer. So times -1, times -1, times -1, times -1. And we have our answer. We have our point of intersection sitting right here. We can say from this line that x is equal to 1, because the y and the z are zeros. Y is equal to -2, and z is equal to 3. So we can say the point of intersection is 1, -2, 3. Round brackets for points. So these 3 planes bump into each other at one point, and that's located in 3 space, because planes are 3 space. It's located at 1, -2, 3. So back to this, I went row 1, row 2, row 3, and then I went back to row 2. So this is the order of the major math that you are supposed to pull off for these questions. Okay, this is for 3 letters, which is the same thing as 3 planes. I'm only saying that because when you get up into 4 letters and 5 letters and 6 letters, which serve purposes other than intersections of planes, They help you solve problems that are not something that you can actually picture, if you can picture 3-space. But if you get more letters, you're going to have to expand on this. So if it was 4 letters, I'd do row 1, row 2, row 3, row 4, row 3, row 2. So I kind of backtrack. You don't often get up into that for the purposes of this. What you do is you resort to spreadsheets at that point. Okay, so this is the stuff. I think there was some other questions, but I think I dug out some new ones. But please check the Google site to double check what I've actually put on for this topic. And don't feel obligated to learn matrices, because to be perfectly honest, it's not necessary for the high school curriculum. It will be a bit mind-blowing if you do this in university or college, so you will always have these videos here. Remember, there is a part 2. Anyhow, see ya.